All right, so grade 10s. Today, we're going to talk about prefixes and something called scientific notation. I'm just going to let you know right now that the notes that we're going to do today are actually not in your notebooklets that I have had made for you that you were either going to print off if you could, or just follow along with. This is just a little side kind of note. So these are just going to be some side notes that we're going to do. You can just follow along. You don't have to take notes on them. We'll go through it pretty briefly. But what I will get you to do is just to practice the practice problems when we do get to them. So you can just use loose leaf for that. And then there's going to be an activity that I'll post on the Google Classroom that I want you to do. So you won't necessarily be following along in your notebooklet for today, but I still want you to watch this video because it's very important for us to be able to do all of the physics stuff that we're going to be doing in the future. So it's kind of just helping set us up for that. So what is scientific notation? Scientific notation is similar to prefixes, which is something that we talked about in our last lesson, in the sense that it's just a short way to write really, really either big numbers or really, really small numbers. And when I say really, really, it actually doesn't need to be a particularly big number. It's most common when we have a big number or a small number. So let's take a look at what it is. I want you to take a second and think about what is this number right here, 300 million meters. Do you recognize it for some reason, maybe? If you do, it's because it's the speed of light, okay? Really important number for physics and just for science in general. We call it the cosmic speed limit. Now, how about this number? This is a really small one, 0.0000000000753 kilograms. A little bit less significant. This one is the mass of a dust particle. What I want you to notice here, though, is that one of these numbers is completely huge and the other number is really, really, really small. Now, both of these, there's a lot of room for error. There's a lot of margin for error for us to maybe write out the wrong number of zeros when we're putting it into a calculator. Or, you can even just save us some time not having to write all those zeros. So what scientists did is developed a method to have a shorter way to express really large or really small numbers. This method is what we're talking about today. It's called the scientific notation. Okay, the scientific notation. Scientific notation is based on powers of the base number 10. Now, I know that all of you have learned about bases and exponents and powers because I'm teaching grade 9 math right now, and it's in that course. So I know that we've all seen it before, whether we remember it very well or not. Well, that's why we'll go through a little bit slowly first. So let's take a look at the number 123 billion. So that's 123 with 9 zeros after it, okay? In scientific notation, this is written as 1.23 times 10 to the 11. Okay, it's written as 1.23 times 10 to the 11. And I'll explain to you why. This first number, we call it our coefficient, 1.23. And what you'll notice is 1.23 is here, and then we have 123 here. That's important. Remember that for later, okay? Now, this coefficient has to be greater than or equal to 1, and it has to be less than 10. So what you do when you're taking one of these big numbers and you're turning it into scientific notation is you're getting rid of the zeros, you're kind of forgetting about the zeros temporarily, and you're looking at just the non-zero numbers. And then what you're doing is you're putting a decimal place in a place that will make those non-zero numbers between 1 and 10. You're going to have a little decimal place, right, that you're going to put right here. Can you see that? Is it working? Right there. Didn't work amazing. But you get the idea. Okay, so let's move on. The second number, this times 10 here, this is always called the base. And it always has to be 10 when we're doing scientific notation. Our base is always 10. Now, the base number is always written in exponent form, meaning that it is going to be raised to an exponent or a power. So right here, in our case, that number is 11. So the number 11 is referred to either as the exponent or the power of 10. So I'll say this as 1.23 times 10 to the power of 11. Now, where does this 11 come from? I'll show you right now. Technically, before I put this decimal place here, there was a decimal place hanging out right over here, but we just don't write it because it's at the end of the number, right? So you don't need to write a decimal place at the end of the number. Let's count together how many spaces I have to move it to get it over here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I had to move the decimal place 11 spaces to get it to be 1.23. So basically what I'm saying here is that this right here in this format is the exact same thing as up here, okay? We're just taking that decimal place and we're moving it 11 places. That's basically all it's saying. So to write a number in scientific notation, we put the decimal place after the first digit and drop the zeros. So that's what we did. We did 1.23 and then we got rid of all the zeros. Now in this number, the coefficient is going to be 1.23. Okay. To find the exponent, we count the number of places from the decimal to the end of the number. Or like I said, counting how many places you move that decimal. In the number 123 billion, there are 11 places. Therefore, we write 123 billion as, hold on, my computer's still here right now. We write it as 1.23 times 10 to the 11. Now, these formats right here, these are the ways that it's going to appear on your calculators. Okay, so some of you will have calculators where you'll see it with a capital E. Some of you will have calculators where you have to use this little symbol here. Okay, so I want you to take a look at your calculators and make sure that you can see those. Then you can try it. So these are the notations that we most often use on our calculator. All right, for small numbers. For small numbers, we use a very similar approach, okay? But the only thing that changes is for the smaller numbers, we're going to have a negative exponent. So if there's ever something that's like this, like 0.0000001 seconds, well, what we're doing is we're putting a negative power, okay? That exponent is going to be negative. And the reason for that is I'm moving my decimal place. I want to have a number between 1 and 0, right? What I have to do is move my decimal place to be right here. Does that make sense? You want to have this number be between 1 and 0. What I'm doing is I'm moving my decimal place 1, 2, 3, 4, 5, 6 spots. So that's 6, but it's -6 because I moved it to the right. So if you ever move to the left, it's going to be a positive number. And if you're ever moving to the right, it is a negative number for this. Or you can just think about it as if it's a really small number, then it's going to have a negative exponent value. If it's a really big number, it's going to have a positive. So I want you to pause the video now. So try these 3 examples on your own. Okay, so pause the video, try those 3 on your own. And next lesson, I'll post the answers. Okay, so try them right now. And if you have tried them already, let's discuss prefixes. And prefixes is going to be your actual little activity that I want you to do after this video. So we have just seen that scientific notation is nothing more than just a shorthand method of expressing either really big or really small numbers. Okay, there's another way to be able to express really big or really small numbers, and it actually requires a lot less math. Some of you might like this way a lot. Okay, this method is called using prefixes. So this method basically takes a really small term or takes a really big term and puts it into numbers that can have a prefix unit attached to them and have them be very regular size numbers. So in order to be able to do this, you have to know how to use scientific notation properly. So make sure that you understand what was going on in the last note, because when you do the activity, there's going to be some scientific notation involved. So several powers shown by the exponents in the scientific notation are assigned letter symbols that we call prefixes. You're going to see these in the little PDF that I'm going to attach to the Google Classroom document. Okay. There are 20 powers that are assigned prefixes in what we call the SI system of units. The SI units are just what we use in the science classroom. So you're going to search for the prefixes. You can do that right now using that activity that I attached to the Google Classroom post. But if you want to, before you get started, you can follow along. I'll do an example with you for right now. So converting numbers in scientific notation prefixes. So maybe go and take a look and you can see what all the prefixes are. Some really common ones are you take meters and you convert them to kilometers, or you take meters and you can convert it to millimeters. That's either taking it and making it a bigger unit of measurement or a smaller unit of measurement. So on your sheet, you're going to have these little x times 10 to the n terms, and you're also going to have a prefix associated with that. What you need to do is you need to take that x times 10 to the n term and replace it with the appropriate prefix. So what I see here is 4,000. When I see 4,000, I see 3 zeros here. If I see 3 zeros, I know that that is the scientific notation term times 10 to the 3. Sorry, my writing is terrible there. Times 10 to the 3. And then what I do is I go on that sheet and I look and I see times 10 to the 3 is the same thing as a kilometer. So this then becomes 4 times 10 to the 3 meters, or better yet, 4 kilometers. Pause the video now, try these next two if you want. Okay, 0.000000003. That's 3 times 10 to the negative 9. So you count out all those zeros, all those decimal places. You have to move it to get it right here. And if you count those out, you'll see 9. So that's 3 times 10 to the negative 9. You see times 10 to the negative 9 on your sheet. That is nanoseconds. And then finally, 4,700,000 moles. This is a unit of measurement for atomic mass that we use. So a mole, 4.7 times 10 to the 6. We see that there's 6 in order to be able to move it to be between 1 and 10. And then that would be mega times 10 to the 6 is mega. So it's 4.7 megamoles. Okay, now what if I wanted to go from a prefix to a standard notation? You basically just do the opposite. You change the number to be in proper scientific notation, then you change the number to be in standard notation. What I mean by that is 3 kilometers. You look at your sheet. Kilo means times 10 to the 3. So then that would be 3 times 10 to the 3 meters. And then I get rid of times 10 to the 3. I turn that back into 3,000 meters. So you can go either way. Micro, if I look at that, micro, 10 micromoles, that's either 1.0 times 10 to the negative 9, or it's 10 times, or times 10 to the negative 6. So it's 10 times 10 to the negative 6, which if I move my decimal place, gives me 0.0000010 moles. And then the last one, 4.7 hectograms. So you find hecto on that sheet. It's times 10 to the 2. So times 10 to the 2, we take that decimal place, we move it 2 places to the right, and that gives us 470 grams. We're going to end our notes there. And what I want you to do is, if you haven't already, finish up that prefix sheet that I attached to the Google Classroom post. Okay? So have a good day, and we will move on tomorrow.